Yep, I think others are not coming. We'll start. They will follow recordings. Yep. In previous class, we discussed how to generate jar file, right? How to generate jar file. Yes or no? So today class, we will see how to submit jar file to standalone cluster and Yarn cluster. Okay. So let's see. Let's open previous example. Spark and Scala. In that we created workspace, which is our project. Spark and Scala, I think, right? In this we created class word count. Yes or no? We created word count dot Scala. So it requires 4 arguments, right? Yep. So it is generated jar file spark SQL underscore 2.11.11 hyphen 0.1 jar file. This is generated dynamically. So up to this part we seen in previous class. Today what we are going to see, we see how to submit Spark application to standalone cluster. How to submit Spark application to standalone cluster. Okay. Standalone cluster follows master slave architecture. Standalone cluster follows master slave architecture. In Cloudera, I have Cloudera installed in my machine. In Cloudera, already Spark is installed in my machine. Spark is installed in my machine. So let's see computer, file system, under file system, lib, under lib, you will see Spark. Sir, under not lib, under USR, under root, under USR, under lib, you will see Spark. Spark is already installed in this machine. Spark. So here in this machine, in this Spark, we have SBIN directory. Under SBIN directory, we have Spark master start script, start hyphen master to start master process, and start hyphen slave to start slave mission. We have two scripts, one to start master, another to start slave mission. So in this Cloudera, so this is our application, Spark application. So we are submitting Spark application to standalone cluster. Standalone cluster. We are submitting our application to standalone cluster. Okay. Here we have two processes. One is Spark master, and Spark slave process. Spark master and Spark slave process. So we convert this one into jar file, right? We convert this one into jar file. We already converted this one into jar file. Example, word count dot jar file. Then we submitted this jar file to Spark master. So first we submit our Spark application to Spark master. So before submitting Spark master, we have to start a Spark master. How to start Spark master? Okay. Let's open command prompt. Let's open command prompt. Then dot or sudo. Let's go to that directory cd slash usr slash lib slash spark slash sbin. Then sudo dot slash start hyphen server or master. Start hyphen master dot sh. It will start master process. It will start master process. Once it will start master process, open browser. Open browser. It will start master web URL. So it will start master web URL localhost colon. So master URL web port is 8080 181800. Press enter. Localhost colon 18080. So this is the master process. So this one is master URL. In our regular classes, configuration time, conf.set spark.master we pass local, right? In that place, pass this master URL. So pass this master URL. That's why in our Spark application, Spark master, we are taking command line argument. Master may be standalone master, master may be yarn master, master may be Mesos master, right? That's why we taken command line argument. Okay, okay. So our master URL is Spark master URL is Spark master URL. Spark master URL. So this is Spark master URL. Next one. Next one. In application, we are taking application name. Application name can be any name. Next, input file and output path. Okay. So input file I am showing here. Let's go Hadoop name node utilities browse file system. Here we have a Qt. Under Qt we have a file. Let's take comment file or create a new file cat spark, then write some message. Spark is a big data processing engine, big data processing engine, big data processing engine. Spark can process huge volumes of data, huge volumes of data, huge volumes of data. Spark is in memory computing, in memory computing. Just we return some message. Control D. Place this one to Qt directory. So Hadoop fs hyphen put spark into under root under Qt directory. So input file is passed. Then output directory we specify runtime. Output directory we specify runtime. Okay. So successfully placed. Let's refresh. So we see Spark, right? Spark file. Okay. Now what I'm going to do is, so we started Spark master and we have web URL. Now next start slave process. Start slave process. So how do we start slave process is, Again, we use command start hyphen master, right? Here, instead of master, we use start hyphen slave dot sh. That's it. It will start. Yep. So we are getting error, right? So to start a slave mission, we have to pass master URL. We have to pass what? Master URL. So what is the master URL? So this is a master URL, right? Pass this master URL. Pass this master URL. Then it will start slave mission. Then it will start slave mission. Okay. So slave mission is started. Once slave mission is started, then we have a jar file, right? So this is the jar file. Right click on it, copy jar file, go to our Linux machine, Cloudera machine, just paste that Cloudera jar file. Paste our jar file. So jar file is placed. So once jar file is placed, then after that we have a jar file. Master is started and slave is started. I want to know whether slave is started or not. We started slave successfully here by using this command. But I want to know whether slave is started or not. Let's open master URL. See, currently there is no worker mission, right? If you refresh, you will see worker mission information. Worker mission information. This worker mission contain how much of GB RAM? 2.7 GB RAM. And how many cores are presented? One core is presented. One core is presented. So like this, you can start multiple slave missions. Why do we are starting slave missions? Slave missions process your Spark application. Okay. So slaves are working, master is working, slaves are working, master is working. Then submit our Spark application, Spark jar file. Submit our Spark jar file. Okay. How do we submit our Spark jar file? Let's go to desktop, cd desktop. Okay. ls, we have a jar file, right? So this is the jar file. Then how do we submit is spark hyphen submit, spark hyphen submit, slash means continuing next line, and here hyphen class, and what is the class name? Word count. What is the package? com.qt.word count. So class name is com.qt.word count. Class name is this one, class.com.qt.word count. Next line continuation. So next one, uh, Spark jar file. Where is our Spark jar file? In same location, right? Same location. So Spark hyphen jar file. So jar file is presented in this location. Jar file is presented in this location. Okay. So we pass jar file name to our application, our server, using file colon slash 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 triple slash. Next one, what is the master URL? So first argument, first, oh, oh, yeah. Mhm. Okay, next line, See, first one, spark hyphen submit, class name, and jar file location, Next one, Uh, First argument, pass first argument. What is first argument? So Spark master URL, right? First argument is master URL. Master URL. What is second argument? Second argument is application name, word count. Second argument is application name. What is third argument? HDFS file location. HDFS colon slash slash local host colon localhost colon 8020 slash, what is our file name? Input file name Spark, right? Slash, and what is output path? HDFS colon slash slash localhost colon 8020 slash. Yep, here we forgot one more point here. Oh, oh, oh. Input path Qt, right? Qt. Input path is Qt. Qt slash. So Spark hyphen submit input path, then output location HDFS colon slash slash. We get error because it is added multiple syntaxes. HDFS colon localhost colon 8020 slash Qt. Under this Qt, Spark Spark submit output. Just I am writing SS output. Let's take complete query now. So this is actual query. Let's press enter. So what will happen? Oh, here we didn't remove Spark command. That's it. Let's press enter. If everything is success, we'll get output com.qt.word count. We are getting error. Class not found exception. So let's see what is our class name. Word count, right? Word count. But it is saying word count class is not available. com.qt.word count. Perfect. Same word count only. Spelling is word count, right? WORD count. Let's see what is the name we given here. We already did everything. Package means it will compile. If it is not compiled, it will compile. Let's open our Spark program. Batch 3 workspace Spark SQL, right? Let's go here. Open CMD. Let's go CMD. Type SBT clean. SBT clean. Next, let's type compile for trying whether it, what is the command? Compile. Yep. First of all, we need to enter into SBT cell here. We need to enter into SBT cell. Sorry. Let's type SBT. Clean. Compile. If there is any already predefined compiled files are available, clean command cleans that one. Compile generate new .class files. Next package. Package is success. So go to here, go to workspace, go to target, go to Scala class. So this one is generated 6th, right? 6 9 30. Time is perfect. Then go here, minimize this one. What I want to do is I want to remove this one. Okay. Then just I want to drop here, drag and drop. So file is dragged, drop. Once again make full screen, and once again execute command. So still it's saying class not found. Spark. Oh, first of all, jar file does not exist. It's saying jar file is does not exist. So this jar file is presented under where? It is presented under home class. We have already jar file, but we thought that word count class is not available. It is already presented in jar file. It's saying jar is not available. Under home, under Cloudera, under desktop slash spark SQL hyphen uh, underscore 2.11 hyphen 0.1 jar. Let's press enter. Now it will work. We executed perfectly. Only one thing is jar file is. So it is successfully executed. Started a Spark jar. Successfully started. Then program is executed successfully, and it is created output. It is generated output. Yep. We are getting error because let's see. No, we cannot get error. Let's open browser. Here you will see running applications. Let's refresh here. It will show running application information. So application is completed. Word count application is completed, not running. So finished. State is finished. If you go browser, if you go refresh here, you will see SS output. SS output. Under SS output, we have two files. Part hyphen 5 zeros, part hyphen 4 zeros 1. Let's click on download. Let's click on save. Let's open this one. You will see. So is repeated 2 times, scan repeated 1 time, data repeated 1 time, big data repeated 1 time, computer repeated 1 time, engine repeated 1 time. Let's go next part file, download, save file, open this part 1. So volume repeated 1 time, spark repeated 3 times, processing repeated. So it is displaying all the words, right? Yes or no? Okay. Now, now, how to stop a spark slave machine? First, to stop slave machine, just use sudo dot stop hyphen slave dot sh dot slash stop hyphen slave dot sh. Next one, stop hyphen master dot sh master dot sh. In this way, we stop and start and stop standalone master and standalone slave machine. Next one, how to submit how to submit how to submit Spark application to how to submit Spark application to Yarn cluster. How to submit Spark application to Yarn cluster. Only one change is just we pass master URL, right? Here we pass Yarn client. That's it. Everything is same. Only one thing, we pass master URL, we pass yarn-client. Yarn-client. How do we know application is running or not? So if you open here, here you will see I'm opening duplicate tab. 50070. So here you will see one process called Yarn Resource Manager, right? Click on Yarn Resource Manager. It will show all the running applications. Currently there are no applications are running, right? Let's start same application. Sorry, this is our application, right? Same application. Here, instead of this master URL, instead of this master URL, this is master URL, right? This one is master URL. Here we pass yarn-client. Yarn-client. That's it. Press enter. Refresh this one. Refresh. 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 So this is the application creator, right? Application. Application name is word count. Spark. State is accepted. Not finished. Not finished. Let's refresh this one. Let's refresh. Refresh. So state is running. Refresh. 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 State is finished. So application execution is completed. Application execution is completed. Only one thing is problem is output directory already existed. So SS output 1. I am giving SS output 1. So application is started. Let's refresh. Let's refresh. So second one also started, finished, succeeded. Previous one is undefined, but this one is succeeded. Because why it is succeeded? Directory is different one. Let's go browser. Let's go name node URL. Here refresh. So SS output 1. Let's once again, it's processing, not completed. I allocated only one processor for this mission. That's why it is taking time. Other than that, nothing. In our real-time application, multi-core missions are available. So we cannot see this delays in real application development. So SS output 1, we see these two files, right? Download, and we can see output. Save file. So go here. So this is the output. Right? We got it right. So that's it for Spark submit utility. That's it for Spark submit utility. Do you have any queries in today's class? Hello team. Do you have any queries in today's class? No, right? So try to execute this Spark submit option in your system. Create sample application and execute this Spark submit utility on on both on both standalone cluster, and next one is Yarn cluster. Okay. Yep. Yarn cluster. Yes, Ravi. So from this, our Spark SQL is completed, and today we are going to start. We are going to start one important one, Spark streaming. We are going to start Spark streaming. Spark streaming will take mostly 1.5 hours tomorrow. Same time. If it is not completed in tomorrow class, we'll take a day after tomorrow, and we'll finish our Spark course day after tomorrow. Okay. Let's start Spark streaming. Let's start Spark streaming introduction. Spark streaming. What is streaming, Ravi? First of all, what is streaming, Ravi? What is streaming? Continuous flow like queues. Okay. First, let me check Ravi's answer. It is a sequence of flow. Perfect. Continuous flow of data. Prasad, correct. Like queues. Yep. You are almost. You are correct? So continuous flow of data is called a stream. If any source is generating continuous flow of data, if any source is generating continuous flow of data, we can read that data by using streaming applications. So we have two kinds of applications: batch processing applications, stream processing applications. What is batch processing, Prasad? What is batch processing, Prasad? Interval of data. No, not interval. In batch processing, we perform first reading data from external source and we load it into our system. After complete loading is completed, then we apply processing operations. We apply processing operations. After processing operation is completed, then we write results of processed to specified location. So this complete process is called batch processing. First we load data completely into our memory. First operation. After loading data into memory, we apply processing. After completing processing, we store result into specified memory location. It may be memory location, it may be storage, it may be any, right? So this process is called batch processing. What is streaming? We are getting data continuously. So we cannot say when data is going to stop. We are getting data continuously. Some interval of time we are processing. So data getting continuously, we are processing parallelly and results are going to store parallelly. So first we are getting data continuously. Some period of time, maybe 5 minutes, 10 seconds or 20 seconds, we execute processing parallelly and result we are going to store into specified location. So this process is called streaming application. Streaming application. So batch application first to read complete entire data. After that, read completed, we will start processing. After processing is completed, we will store or display the results. We will store or display the results. Streaming means reading or receiving data continuously. Processing means we process live data based on some time gap, mostly seconds, 5 seconds or 10 seconds or 20 seconds. And results immediately we store or display the results. So receiving and processing, we define time gap. Receiving and processing, we define time gap. So Spark streaming is used to streaming data from different sources. Spark streaming is used to streaming data from different sources. It may be local file or HDFS file. It may be network port. It may be another application or it may be other messaging system. Input may be any streaming source. Okay. A Spark streaming application can receive data from any streaming source and process the received data with the processing interval minimum of default 1 second. Minimum of 1 second. So you can define this time interval. We can define this time interval. Example, I'm getting continuously chatting data. In that chatting data, every 10 seconds or 20 seconds, I want to display how many good words are tweeted, how many average words are tweeted, how many bad words are tweeted. So we posted message on particular product, XYZ product. In some social media. So people are buying and giving some feedbacks on that product from different vendors. They are buying the product and giving some feedbacks. So every 10 seconds, so data continuously generating on that product. So that product owners wants to do some analysis on that product. So they want analysis like every 10 seconds, they want to see how the people are giving comments on that product. Then we use Spark streaming. Okay. So like source continuously generates the data. Spark streaming application receives process parallelly. Results stores in target location. It may be HDFS, it may be Kafka topic, it may be other systems. Okay. So complete processing is happen inside in memory or disk memory. By default is in memory. In application, in Spark streaming application, we can configure you want to process or store this batch data into in memory or disk memory. This is our wish. We can configure. Depends upon our client requirement. We can configure this processing location and batch creation location. Okay. So here two terminologies are important. The amount of data that get collected within that time gap is called batch. The amount of data that get collected is called batch. So the time gap within the time gap is completed, then it will start the processing, right? So that time gap is called sliding interval. The interval in which the data gets processed is called sliding interval. The amount of data with with it gets created within that time gap is called a batch. The interval in which that gets processed is called sliding interval. So this is very important terminology. Very important terminology. Okay. So if you want to implement Spark streaming applications, we need to add Spark streaming dependency into build.sbt file. Next one, we need to import org.apache.streaming.underscore package. org.apache.spark.streaming.underscore package. This package contains set of predefined classes, Scala classes or Java classes, which can be used to perform receiving operation and processing operation. Okay. So if you want to implement this, see, receiving is happen parallelly, processing is happen parallelly, right, Prasad? In streaming application, receiving is happen parallelly, processing is happen parallelly, right, Ravi? So if you want to implement a Spark streaming application, compulsory you must have minimum of 2 core processor. Minimum of 2 core processor. Otherwise, it may take longer time to process your request. It may take longer time to process your request. So multi-core processors are important to implement your Spark streaming applications. Okay. So tomorrow class I will clearly explain. Let me finish this one first. Yep. One application is there. So instead of executing this application, tomorrow class I'll explain this application. We have 3 or 4 applications. We'll try to finish complete applications in tomorrow class. If it is not possible, then day after tomorrow we'll take half an hour or max half an hour, 40 minutes. Then we'll finish the Spark streaming. Then we'll start some use cases. Okay, so that's it for today. If you have any queries, we'll discuss it. Otherwise, we'll stop here and we'll continue tomorrow. Yep, tell me, Prasad. Our application is driver program. First of all, remember Spark architecture. In Spark architecture, I explained one important concept. Our application is driver program. We submit our program to cluster. Okay? Yep. We'll continue tomorrow. That's it for today. We'll meet tomorrow.